Hi, I'm Mr. Franklin, and this is a recording of our live Zoom session from September 8th and or September 9th. In case you missed it, I know some of you have had power shut down and even maybe evacuated for fires. So this recording is specific for everyone, but it's specifically for you so that you can at least know what we talked about, kind of watch and see what's going on. The Pear Deck that goes with this. The Pear Deck is student paced, so you can also click through it in case you miss something. There are some really important things for you to think about as we go through this. All right, so your first question in the Pear Deck is to look at the overview of the whole week and tell me what parts make you excite you about this week and what part makes you nervous. So you can pause the video right now and answer that question in the Pear Deck. This actually helps me. It gets you thinking about the week, but it also helps me know where you're at in everything. So please make sure you answer that for me. I do come back later at the end of the week and review this stuff as I prepare for the next week. Welcome back. Here are some of the answers that some of people put for the live class. And I like to show this because hopefully it'll make you feel like you're not alone. Looking at the agenda for this week, it makes me a bit nervous because I should really catch up, but also doing everything I should be doing so that I don't fall behind. I think that's really going to be important as we talk about grades. It's also going to be important because everything we're doing is going to build to the next thing. So you really got to fight hard to not get behind. If you need help, make sure that you're coming in for my office hours in the afternoons from 1 to 2:15. Send me an email first, but I'll set that up in Zoom. The vocabulary looks exciting. So they were excited about the vocabulary because it's new words or maybe even familiar words. Well, something that makes me nervous is the introduction to the quarter project. So we're going to be talking about that. Most excited is talking about Newton's first law. I would be curious to hear why. Maybe that's just because you're familiar with it. Most nervous is vocabulary because new words can be difficult. I'm more excited to take notes because I can practice to know how to do them without looking at examples. I like learning for learning's sake, and I hope that's where you actually are. It's so difficult when school is all based around a grade and not necessarily grades are supposed to reflect learning, but somewhere in that we lose this idea that learning is just cool and learning new things is good for you. So our objective for this video is we're going to talk about grades real briefly. I'm not going to spend too much time on the weekly overview because you can read that in Canvas. We are going to go over how to log in to our first gizmo. Unfortunately, there's some part of it that I can't see because I am not a student. And then we're also going to talk about Newton's first law and unchanging motion and introduce the quarter project. So that's actually quite a bit, and we'll try to get through it as quick as we can. So without further ado, grades. Grades have now been transferred from Canvas to Aries. I've graded the first 2 weeks of school and put those into Aries. Aries is the school's official grade book. So if you want to know what's going to be on your report card, you got to look in Aries. If there's a discrepancy between what's in Canvas and what's in Aries, that's definitely something you need to let me know so I can take a look at it. If it's just missing and it's also missing in Canvas, well, then you probably need to look in Canvas and make sure that you submitted the assignment. Report cards do go out at the end of this week. It is a progress report. So it's midway between the final grade for this term. So our school, we use we're on a quarter system. So instead of semesters and having 2 semesters in 1 year, we have quarters. And we have 2 quarters in 1 semester. So these 2 quarters make up a whole year's worth of learning. So this is the halfway point at the end of this week, the halfway point for this first quarter. So many of you are missing something. I think there's only a handful of you that have completed every single assignment. So if you're missing something, you have until Friday to get it in. So I can get it into Aries, and you have until Friday if you want to end the report card. If you just can't get it into me by Friday, I will still give you credit. It will still go in your into your grades in Aries, but it will go in for the final grade and not just a report card. So if you wanted it to reflect for your report card, which goes out to your parents, make sure you get it into me by Friday, so we can work something out. So speaking of missing work, week 1 and 2 have passed their learning usefulness. So that means you can still turn them in for up to 50% credit, but because we've already taken the test, it's not as useful for you to do all that work, but still it could help you. 50% is way better than a 0. Module 3, which is last week's work, you can still get full credit, even if you turn it up to a week late. So you have until Friday to get that turned in for full credit. And then you're also working on this week's work. So try not to get behind any more than you may already be. With that said, I am a very generous person when it comes to grades, especially if you're communicating with me via email and letting me know that you're having this problem or this is going on. Because some of it, you may be struggling with something and I have no clue that you're having this struggle. And I just think, oh, well, they're not turning anything in. So make sure you're communicating with me and we can work something out. There's a couple of you that have emailed me about week 1 and 2, and I'm actually going to give you full credit because you've been communicating with me. So like I said, I'm very generous about this, but this is the official policy. And so I'm going to try to stick to that. But I also know we've got technical issues. We've got all kinds of things going on in real life that we need to be mindful of, okay? So if you have any questions about grades and the progress report, you can type that into the Pear Deck. Honestly, the most important thing you can do is, and if you have no questions, put no questions. So let's hit a couple of these from, okay? Do late assignments show on the report card? If there is no grade, late assignments will be counted as missing assignments, and those in the grade book, if they're put in, so week 1 and 2 have been put in, and if one of those is missing, it will count as a 0 in the grade book, okay? It will show no grade in the grade book in Aries, but it will count as a 0, okay? Where does it come? In our email. Okay, so your report card will come, generally it comes in the mail. There may actually be a digital version that comes out this time because of Aries. We have a new grade book, so I'm not 100%. Usually, traditionally, it comes in the mail. So you might get a digital notification, but you should also get a paper copy of it as well. First quarter ends October 9th. Progress reports come out this coming Friday. Yes, if you have something missing or have problems, email me. So if anything from last week, turn in for full credit. So if you are behind, I would probably start with last week because you can get full credit. So start with last week and then go back to the week before and then the week before, okay? Also, you can visit me during office hours, and because I've done this, I did this this morning actually, where we went through online and they stick around after class and we worked through how to get access and turn something in because they had done it, but they just hadn't turned it in. So please let me know that. Any other questions, please email me. Let me know what block you're in and I will get back to you. Just be aware that I'm getting 50 to 150 emails a day, and that takes a lot of time to get through each one of them. So, but still, email's the best because I have it in my inbox. Okay. All righty. Okay. So this week, because of the holiday and also because of the Valley Fire and some different things, I did not assign our traditional Monday for Monday per se, but you should do this first, the what do you think, and start making your vocabulary flashcards. There are a ton of words for this unit, and all the words are specific. So make sure that you are getting your study prep prepared and start studying those. So today we're going to talk about this fan cart physics. Some of you have already done this, but you have your video notes on Newton's first law, inertia, and constant speed, and you have a textbook time on a similar topic. So basically, Monday, yesterday, and today, because we're already on Wednesday, you should be finishing all these. On Thursday, we're going to continue, we're going to expand and talk a lot about motion graphs and what it means. We're going to spend some time in a gizmo where we're going to watch an object move and see what the graphs look like. And we're going to get to mess with that as a lab. And I'm also going to be releasing tonight this last assignment here, which is more details on your quarter project than what we're about to talk about. And then there will also be your weekly quiz and then your self-reflection at the end. Okay. Just please note, please do your best and be honest with yourself on the self-reflection. There's no right or wrong answer except that you leave it blank, then I give you 0 points. So please fill in stuff. It is meant to help you go, you know what, I'm not doing what I need to and I need to do this. I also read those, and when I notice trends, like everybody's putting the same thing, then I can start making videos kind of like this one, where I just go over that one topic. So I haven't really done that yet, but that's something I can do for you. Okay, alrighty. So quarter project, like I said, we don't do semesters, we do quarters. So you have 2 quarters for this class. And each quarter, you're going to have a quarter project. The quarter project is 10% of your overall quarter grade. Now, most of you will do basically the same level of work that you do in your other work for this class. And so your grade's not going to go up or down by a whole lot, okay? However, if you're sitting at an 88, and you do really well on your quarter project, there is a very good chance it will bump you up to the 90% that you need for the A. If you're sitting at a 58 and you need that D, okay, a 10, if you can really do well on this project, and I think you're going to find this one's actually going to be fairly straightforward. I won't say easy because that would be misleading, but it's going to be pretty straightforward what you're going to have to do. It's not going to be too complicated. I think you can actually raise your grade by a letter grade, generally. Now, if you already got 100% on everything, then you're probably going to be fine. But if you don't do anything for this quarter project, it will probably drop your grade by a letter grade. So that's how much 10% affects your grade. It can affect your grade up to a letter grade. So take it seriously, do your best on it. And yeah, hopefully we'll learn and get to watch some exciting videos, because this quarter project, the quarter ends October 9th. So I want you to turn in the quarter project on October 7th so I can get them done by the 9th, because that's when I have to turn everything in for grades. So October 7th is the deadline. There is no late work. There is no 1 week later I can turn this in. There's none of that. You've got to get it to me October 7th. So honestly, that's probably going to be the most challenging part of this, is you've got to have everything done and completed for this project by October 7th. There will be an opportunity like the week before to turn it in early so that you can make sure that you get it turned in, and that'll just help you know where you stand with your grades. Okay, so there's a lot more to that, but that's just, we're doing an intro. The quarter project will be independent. You're going to work alone, not in a group. So this is totally up to you how you do. For this project, you're going to critically review TED Talks. So I'm going to show you what a TED Talk is for those that don't know, but you're going to find 3 TED Talks, and 2 of them need to be scientific in nature, and the 3rd one can be about whatever you are interested in. All 3 of them could be about science and engineering, and that's great. Okay, there's plenty of talks where all 3 of them could be science and engineering related, but there are some excellent ones on leadership. So maybe you want to watch one on leadership, or you want to watch one done by an athlete, or you want to watch. So there are some excellent TED Talks out there that you can talk about. Okay, so we're going to talk about what a TED Talk is, because you can't just pick any YouTube video. Okay, it's got to be we want it to be a TED Talk. Okay, what you're going to do is you're going to tell us a little bit about what the person talked about, and then you're going to review each one of these TED Talks in writing. So you're going to have 3 little pieces of writing that you're going to have to do on each one of these. And then you're going to pick one of these 3. It doesn't matter which one. You're going to pick one, and you're going to make a video presentation of your writing. So you're going to have to write on all 3, and then you're going to have to do a video on one of them. Okay? The video will either be in Flipgrid or it will be in with Canvas's video submission tool. And we'll talk about that later. Okay, so we're going to talk more in detail because I've got a rubric. I've got specific questions I want you to address as we go. Okay, but before I ask my question of you, I want to show you what a TED Talk could be. So if you've ever watched Vsauce or heard of Phil Plait, he did a TED Talk. So TED usually has this red logo. So this one is a TEDx Boulder. So Boulder University put on this TED Talk, and they invited him to come speak about science. Okay.
Now, people have a lot of misconceptions about science, about how it works and what it is. A big one is that science is just a big old pile of facts.
So things to note, this actually has the logo of TED. In other words, it's been filtered by a body. Some of them are actually the official TED organization, okay, that selects quality speakers. There are some, like this one, which is an independent TED Talk, but it's still been filtered by a university. Okay, so here's one done by an independent TED Talk. Clemens University. Okay.
So our sun is a single star among billions in our Milky Way galaxy. And this is a galaxy very similar to that. The Andromeda galaxy next to it, our neighbor in space, spinning around like a giant wheel in space.
So it should have the TED label, and you're going to need 2 that are about science and 1 that could be about something else. I really like this TED Talk because he actually argues that dark matter does not exist, and he explains why. And that's part of what you're going to be doing is we've been talking about claims and hypothesis, and we've been talking about data and evidence and analyzing those things. You're going to talk to me about, in your paper and your video, about what kind of claims is this person making and what kind of evidence are they using to convince the audience that what they're saying is a good thing or is the right thing to think about, okay? So that's the gist of what you're going to be doing with this quarter project. Okay, so in the Pear Deck, I'm sure you have lots of questions, okay? So because the Pear Deck you can still put in questions in the Pear Deck, you can go ahead and add more questions to the Pear Deck. You can also email me, but the purpose of these questions is so that on Friday, when I release that assignment, I can address many of your questions that you're having. So if you need to pause it, go do that. So if you go to class and you're going, I don't know where to go. So we're at home, and let's do student view. And you're like, there's stuff everywhere. I got all these assignments to do. I got all these dates. Where do I go? Go to modules. And your modules are probably all expanded, most likely. So you have all this stuff. So first thing you should do is go over to the left side and minimize each of the modules. So on the left side at this little arrow here, minimize, minimize, and minimize. So the current, these are all done by week. So the first week of school, second week of school, third week of school, fourth week of school. So if you click here, this is the last one, is the week we are on right now. And so we are actually on this Zoom right here. This is where the Pear Deck is. Okay? And here in a minute, we're going to do these 2 things together. So I just wanted to, I meant to do that earlier, but I want to make sure that you're all following along with me. Okay. Vocabulary for today. There are 3 vocabulary words. because some of you may or may not have done your vocabulary study or started it yet. We want to make sure that you understand. So this is a question I asked in class, and I'm going to go ahead and ask it this way, and then I'm going to explain. So have you ever heard this definition for mass? Mass is the amount of stuff in an object, or mass is the amount of matter in an object. Have you heard that definition before? So most students, when I ask them that, they've had a good science teacher, and that's usually the definition they've heard. That's the definition I usually teach when I teach chemistry, but that's actually not quite the correct answer, especially in a physics class, okay? In physics terms, mass is the amount of inertia an object has, which is very strongly connected to how much matter is in an object, okay, by definition. But the idea of mass was really coined by Isaac Newton, and he said it's a quantity of inertia. It's how much inertia an object has. So what is inertia? So I hate it when, and this is what we do in science, right, is we put science words in our science definition, and we're going, oh, what does that mean? So inertia is basically Newton's first law, okay, because that's the law of inertia. So inertia is an object's tendency to maintain its motion unless a force changes it, okay? So mass is a way of counting how the tendency of an object to sit still or to keep moving once it's already moving, okay? So mass is a measurement of inertia. However, to keep it simple, and when you're really thinking about it, if it's got matter, it's got mass, Newton's first law applies because it has inertia. Okay, so that's mass. Force, push or pull. Okay, we should already know that. Velocity. So some people don't know this, some people do. Are speed and velocity the same thing? Are speed and velocity the same thing? And the answer, of course, is no. They are not the same thing. So I could say I'm going 60 miles per hour. You'd be like, okay. Or I could say I'm going 60 miles an hour north towards Los Angeles. Well, if I said that, then you would know exactly which direction I'm headed, or better. So velocity is speed and direction. And you're going to find in this class, everything we're going to talk about has to do with direction. Forces, direction is important. Velocity, direction is important. Everything has to deal with what direction is it happening. That's called a vector. Okay? All right, so that's kind of the vocabulary we're going to use in our lab today, those three words. So real quickly, Newton's first law. If I asked you this even before class, most of you could probably tell me this definition. You probably all know this definition or some version of it. Newton's first law says, an object at rest will remain at rest unless acted on by an outside force. An object in motion will stay in motion unless acted on by an outside force, or a net force, or a unbalanced force. Those are all ways of saying the same thing. So let's take a look at this. So if I put my phone on my hand, there are multiple forces acting on the phone. So there's the force of gravity pushing down, and then there's my hand is pushing back and holding the phone up. So, but both those forces are balanced out. So as long as the phone is not moving, okay, right now, forces are balanced out. So the net force, net means total force, the total force is equal to 0. So the phone is just going to sit there. It's probably easier because my hand might wiggle a little bit. It's probably easier if I put it on the table and just set it on the table. So you have the force of gravity and the force of the table, and the phone is just sitting there because the net force is 0. Now, if I push the phone, okay, we actually have the force of my push. As long as the phone is moving at a regular speed, friction is pushing back at the same rate, and still the net force is going to equal to 0 as all the forces are adding up, okay? So back to this analogy, force of gravity, force of hand, object's not moving. All of a sudden my hand starts applying more force than gravity, so the net force is upward, and now the phone can be lifted and accelerated, okay? So, an object at rest will remain at rest unless acted on by an unbalanced or a net force. So if you add all the forces together and equal 0, then it's at rest, or it's constantly moving. So now this second sentence is where we mostly get confused and mess it up in physics, because we live in a world bound by friction, and there's almost always an outside force causing the motion to change, okay? And because of that, either because of gravity or because of friction, we always see something being either accelerated or stopped because there is an unbalanced force, okay? So we're gonna look at that when we look at our videos. If you did the what do you think, those videos I hope should have shown you a couple examples of that. So to put it simply though, one way that I like to simplify this definition, because that's a lot to say, but it's really simple. An object's motion does not change unless acted on by an unbalanced force. So if I have a soccer ball and I kick it, generally what happens as it rolls across the grass, it comes to a stop. Well, why? Well, that's because there's a thing called friction, and the grass actually, in a sense, pushes against the motion of the ball and it slows down and stops. So there is an outside force or a net force that is not equal to 0. It's not equal to 0, and so it causes the soccer ball to stop, okay? Now, if we could eliminate that, let's say we take this soccer ball, usually you don't think of playing soccer on ice, but if we could take it to like a place where there's a bunch of ice, we could kick the soccer ball, and now, as long as, if we could have an infinite length of ice, that soccer ball would never stop, okay? As long as the friction was actually 0. Soccer ball would never stop until another force stops it, okay? That's the hardest thing for our brains to kind of wrap around because it's not our almost everyday experience. But the best everyday experience is if you're in your car and you slam on the brakes, what do? You lean forward. That's why you have to wear a seatbelt. That's Newton's first law. You are moving. Because of your mass, you want to stay moving. And so until the seatbelt stops you, you're going to keep moving forward. Okay, so that's Newton's first law. Can you think of a time where Newton's first law does not apply? Okay, when does Newton's first law not apply? You can type that question into the Pear Deck. So pause it now. Pause it. Okay. Welcome back. Here's what some of you put. I liked your thinking. A lot of you did some good thinking when you did this in class. Dry ice and magnets, so you're thinking of a frictionless surface. So I understand what you're trying to say there, but that's actually exactly when it applies the best and it's most visible. In a black hole, that's an interesting question. So we have to understand what a black hole is, and we also have to understand our limitations, the limitations of our understanding of what's going on inside a black hole. So it's a black hole because we can't see inside of it, okay, because light can't escape. But if I tell you the full answer, you'll understand what the whole answer is to my question. When does Newton's first law not apply? When you're in the air or in space or time. Okay, interesting. So I'm going to say, except for this middle one, it definitely applies. We're going to have to talk about what you mean by space, because if you're on the space station, guess what? Still applies. Okay, if we're talking about the space station or an astronaut on the space station, Newton's first law applies. You jump into the air, Newton's law first still applies. When you let go of a balloon, actually, it's because of Newton's first law, the balloon actually flies around in the air. Newton's first law is what helps make it fly around, okay? Pretty cool, okay? It's actually a combination of all 3 laws at work. Okay, going into space, being in a really high place. So we're really gonna have to talk about what everybody means by space, because I think you might be right, but you might also be thinking of something different, okay? Maybe in the water, because water can just go Okay, so the water can go around you, but water follows Newton's first law. So you kick a soccer ball in water, still going to have Newton's first law acting. Space and anything with mass. Okay, I think you're answering the opposite question. Oh, wow. I like what you're thinking here. I like your reasoning. Okay, so you put in space, so we're not real sure what we mean by that, but because if you try to stop something, it will stop and then you will keep moving. Okay, so what you're actually talking about is a phenomenon we will hopefully get to in 5 or 6 weeks, and that's momentum. And Newton's first law still applies. Okay, the moon. Interesting. Okay, somebody's brain is fried. Okay, so lots of good stuff. So let's talk about one of the essential ones, and let's talk about the one that I get the most, and that's space. So in outer space, if you have an object with mass, Newton's first law applies. So here's the rule. If an object has mass, Newton's first law always applies. So this is actually a question of, can you think of an object that has 0 mass? Can you think of something that has 0 mass? And so this is where the space idea might fit the bill if you define it as purely empty space. There is absolutely nothing there. In that sense, you are 100% correct. So it may not be Newton's law applies. It should be more like Newton's law is working or in effect. It's a subtle difference, but it's an important one, okay? But in empty space, there's no mass, so there's nothing for Newton's law to act on, to work with, to show us that it's there, okay? However, actual space is not 100% empty. The space between us and the sun is like 99.99% empty, but it still has particles like protons and electrons and muons and neutrinos and all kinds of particles that are coming from the sun, that are coming from outside our galaxy, traveling through empty space. So if you look carefully and closely through empty space, you will see some stuff. So any of those objects that have mass, Newton's first law is in effect, is working. So now here's the other one. So empty space. The other one that I get that's actually a really smart one to think about is light. But you have to ask yourself, does light have mass? And so Einstein comes along and says light does have mass. And it also doesn't. But because light has mass, E equals mc squared is actually part of that. The camera on your cell phone works. If light did not have mass, then your camera on your cell phone wouldn't work. Okay? So if it has mass, Newton's first law. That's the simple way to put it. Okay, so now we're going to jump over and we're going to sign into Gizmos. I've figured out some things since we did this in class, so this might also help you here. So we're going to go to Canvas and we're going to sign into Gizmo. So when you go to your modules, you go to modules, you're going to skip this. We're going to come back to it because the class code that you need is going to be here. Each class has its own code, so make sure that you go here to find your class code. I'm not going to show you on the video because if you put in the wrong code, then you will cause all kinds of problems. Okay, so join the Explore Learning class. You click on that, slideshow comes up, and click to the third slide, and you will find your class code, which you will need. You can write it down on a piece of paper and then come here or open it in a new tab. Okay, so those slides tell you one way to log into Gizmos, but I've discovered a new way to do it that actually will probably be better for you. So the first thing you should do is go down to the G, so we're Physics Lab 2.7a, and you're gonna go to the G. Now you can do what I recommend is that you right click, 2-finger tap, or control click, but you wanna open the link in a new tab. Just open it in a new tab. And that's because Canvas is dealing with instancing and some different things like that. And with multiple students accessing the same thing. It doesn't quite work the way I want it to. So open it in a new tab, and you're going to log in or enroll. But notice that this box shows up, and the best way to do it is enter the class code and click enroll in a class, okay? The other way to do it is you can, I believe you can just log in or enroll. Student class enrollment, the easiest thing is enter the class code, enter the code, you click enroll. I can't do it because it's gonna be weird because I'm a teacher. So, but you enter the class code, and then it's gonna come up with a screen that says create an account. When you create an account, you're going to have to put in your username. So username, use your first name, and then you can do space, last name, okay? And then your login, your password should be your school login. Use the same login. Later, it should ask you for an email, and then you use your @schscougars.org email to log in. Okay? Now, if you do this in another tab, it should work fine. Some students have had issues with their name not actually registering properly. So you can do like an underscore. But if you do something weird with your name so that it works, make sure you write it down in your composition book and your notes so that 3 weeks from now, when we come back to this and you're like, I don't know how to log in, I'm not going to be able to tell you. And I do not want you creating a million accounts for this, okay? You should only need the one account. Just write down the username you use, and we should be good to go. Okay. If you need help logging in, you need to come visit me at the 1 o'clock to 2:15 office hours. Send me an email, and I will create a Zoom link in Canvas, and then you can join me there. Now you're going to go into the Google Doc, and while the gizmo is open, and you're going to answer the questions. Now this document was created by Gizmos, so you just fill in the boxes. Just fill in the boxes. They are not color-coded like the ones that your teachers create for you, but fill in the boxes and answer those as best you can. When you're done, don't forget the submit button is right here. So where mine says share, yours will actually have a submit button, and you should submit there. And once you click submit, there will be a little message right here with a date. See the blue words? Underneath will be a little text thing that says submitted on, and it will tell you the date that you submitted it on. Don't forget to summarize in your notes, and also you can write one thing you've learned in today's Zoom. That's all I have. If you have any questions, see me during office hours or email me. We will see you in the next class. Thank you. Bye.